Assalamu alaikum, my dear students, grade 12 students, in your second part for the first session in this session, inshallah, we'll talk together about the similarity. Okay, we talked before about congruence and about the congruence of the polygons or the congruence of the shapes. When two shapes are congruent, congruent, it means the same. If we talk about congruent triangles, so you have two same triangles. But similar, it means you have only two similar triangles. Similar, it means they are, for example, a triangle like this, it's right angle, and we have a triangle like this, which is right angle also. So these two triangles are said to be similar in some cases. They are not the same, mister. They are not the same, but I called similar. Similar depend on some cases, but congruent are the same. The sides are equals, the angles or the corresponding sides are equal, the corresponding angles are equals, and also they have the same perimeter and the same areas. But here, we'll talk about similarity. Two triangles are said to be similar if and only if. If and only if. We have two cases. Okay, so two polygons are said to be similar if and only if number one. Number one, the corresponding angles are congruent. The corresponding angles are congruent. So corresponding angles are congruent. So corresponding angles are congruent. Okay. So the angles must be the same, must be equal. Angle number one here is 30. Angle number one here is 30. Angle number one in the first is angle number two is 60. Angle number two here is 60. Angle number three is 90. Angle number three is 90. So the corresponding angles must be congruent or equal. We're going to two. To the sides or the corresponding sides must be proportional. So the sides must be proportional. What's meant by proportional? This what we will say or discuss now. So the sides must be proportional. The sides must be proportional. How, mister? If we have first triangle, for example, I have triangle XYZ, and I have another triangle which is ABC. So triangle here, ABC. So these two triangles are said to be similar if, number one, the corresponding angles are congruent. It means a measure of angle X equal measure of angle A. Measure of angle Y equal measure of angle B. Measure of angle Z equal measure of angle C. Okay, what about number two, mister? The sides are proportional. The sides are proportional, it means the first side here, if we go like this, so XY, for example, XY, so I have here XY, over the first side down, which is the corresponding side, AB, so over AB equals to XZ over the corresponding AC, mister. Okay, and yes, YZ equal BC over BC. So they are equal. It means if the first ratio is equal, for example, is 2 over 3, so the second must be 2 over 3, so the third must be 2 over 3. Okay, so this is the meaning of proportion. This is the meaning of proportion. They have the same ratio. They have the same ratio, or the ratios are equals. The ratios are equals. Okay, so this is the cases for two polygon similarity. Okay, the cases of similarity of triangles. So we talk about a polygon. Now we'll talk about triangles. Triangles. So in triangles, we have 6 elements. It means we have 3 angles and 3 sides. Okay, mister. So you must to say this two triangles are similar. I must know that the three angles is equal to their corresponding angles, and the 3 sides are similar or are proportional with the 3 sides. No. Only we have to get these cases. So no need to complete by the 6 elements, the 3 sides with the 3 sides and the 3 angles with the 3 angles. No, we have cases. The first case is called SAS. Mister, it's the same case for the congruent. No, it's not the same. It means you will have S, it means side, A, it means angle, and S, it means sides. So two sides from the first triangle are proportional to two sides from the second triangle. So proportional, not equal. Proportional, not equal. And included angle must be equal. It means if you have here a triangle like this, okay, this angle, for example, is 50, and this angle is 50. This side is 3, and this side is 5. This side is 6, this side is 10. So they are similar, and this is a sign of similarity. It's like a wave like this. So this is a similarity sign. Why, mister? Because we have included angle are equal, and the first side, which is 3/6, is equal to 5/10. Both of them equals to half. So, mister, two proportional sides and one equal angle. So SAS. Okay, so the length of two sides of the triangle are proportional to their corresponding sides, and the included angle are congruent. What about the second? Second case is SSS. SSS, it means the three sides are proportional. The three sides are proportional. As we said, we have a triangle, we have here X, Y, Z, we have here A, B, C. So it's called the umbrella rule. How, Mr. Triangle X, Y, Z, and the triangle A, B, C. The umbrella rule, it's like this. The first two letters with the first two letters. So X, Y over A, equal. The second and the third, which is Y, Z over the second with the third, which is B, C. And then the third with the first become an umbrella like this. So Z, X or XZ, and we close also here. So becomes the CA. Okay, if you have this case or this case is satisfied, so the second case is satisfied. The second case is satisfied. Pay attention about this small mistake. If you start here up in the upper part by the first triangle, you must complete by the same sequence. It means what? It means I can't say XY over AB must be equal to BC over YZ. You flip here. Okay, so it will be wrong. You must go by the same sequence. You start by this is your first triangle and this is your second. Okay, mister, if I flip, I start by the second and then the first, no problem, but complete by the same sequence. It means if I write AB over XY, it must be equal to BC over YZ. Okay, okay. This is the second case. The third case is called AA. What is AA? Angle. Oh, two angles from the first triangle are equal to two angles from the second triangle. Only two angles? Yes. If this angle is 50 and this angle is 50, okay? And this angle is, for example, 30 and this angle is 30. Then the two triangles are similar. The two triangles are similar. Okay, so if two angles from here equal to two angles or the corresponding angles from the other triangle, so they are similar. Okay, so this is the cases of congruency, the cases of similarity of two triangles. Okay, we're going to the ratio of similarity or the scale factor for the similar. Pay attention with me. If we talk about two triangles, Mr. Okay, the first triangle is XYZ, and the second triangle is ABC. Okay, and the two triangles are similar. Okay, what shall I deduce? You will deduce that XY over AB equal to YZ over BC equal to ZX over AC. This is right, but it's not completed. Equal to the perimeter of a triangle XYZ over the perimeter of triangle ABC. Oh, it means, Mr. The ratio or the proportion includes the ratio between the two perimeters? Yes. It means, Mr., if I have xy over AB, which is, for example, xy is 4 and AB is 5, and you give me the perimeter of the second, which is AB, for example, it's 30. I can find the perimeter of the other, of course, by getting the cross multiplication. Okay, so pay attention about this. Pay attention about this. Okay, so in state of the three sides only, the perimeter over the perimeter is also have the same ratio. Only the perimeter over the perimeter, no. The median over the median. It means the median of the first triangle is proportional to or the median of the second. So the median over the median. Okay. Only the median? No. The altitude of the first triangle corresponding altitude or corresponding height. The angle bisector of the first triangle and the angle bisector of the first. All this in the same ratio, have the same ratio? Yes. If I said, for example, xy over AB equals 4 over 5, so the second side must be 4 over 5. The third side with the third side is 4 over 5. The perimeter over the perimeter, the median over the median, and so on. All this included in the proportion. All this included in the proportion. Okay, okay. We're going to the theorem of the mid-segment theorem and also the proportion parts. This is a very important theorem. Pay attention with me. If we have a triangle, this triangle is called ABC. So I just draw a triangle like this. This triangle is a triangle AC. Okay, we're going to this triangle and I get the midpoint of the side AB. So I just write a point here, and this is the midpoint. I name it by X, the midpoint of AB. It means AX equal BX. Okay. And I put a point also to be the midpoint of AC, which is Y, for example. So AY is equal to CY. Okay. So I have here a midpoint for the first two sides. If I join this line, okay, so I'll join this line, the line that join between the midpoint of the first two sides. What is the relation between this line or the line of joining the midpoints and the third side? The relation will be, they are parallel. Okay, so I can say XY is parallel to BC. Only? No. I can say also that XY equal half the length of BC. Again, mister, this is the theorem. This is the theorem and this is the rule. The theorem said that the lines that join between two midpoints of two sides is equal to half the length of the third side and parallel to it. Half the length of the third side and parallel to it. Okay, so I can say that the bisector segment, it means a line which join between the two parallel, the two sides is parallel to the third side, and the length is equal to half the length of this side. Okay, so this is called the mid-segment theorem. The mid-segment theorem. Okay, we're going to the last point in this lesson. The last point or this theorem, which is called proportion theorem. We're going to the same triangle in order to draw another triangle. This is my triangle like this. Okay, so the triangle ABC. Okay, ABC only. This triangle, okay, if I say that I have a line, this line is parallel to BC. This line is parallel to BC. So I just draw a line like this, and I say that this line, which is called, for example, HG is parallel to BC. They are parallel. From where? From this sign. This is a sign of parallelism. Okay, so I just write HG is parallel to BC. What I can deduce? You will deduce that this HG divide the other two sides into a proportional part. How? It means AH over HB. AH, sorry, AH over HB is equal to AG over GC. So AG over GC. Okay. This is number one. This is number one. You have number two? Yes, I have number two. Pay attention. I can say also. I can say also. AH over the total, which is AB, is equal to AG over the total, which is AC. This is right, and this is right. You can use anyone according to the information. So if you have, I give you this part, for example, it's 5, and this part is 2. This part, for example, is 7, and this part is a space X. So you'll use the first part over the second part equal the first part over the second part and make a cross multiplication. In number 2, if I have to give this 5 and the whole is, for example, 15, and I ask you about the whole here, so you can use the second one. There is no problem about this point. We're going to the problems. Number 1. In number 1, in the opposite figure, two triangles are similar, then the value of A equals. Two triangles are similar. Okay, so the two triangles are similar, so I have the corresponding sides are proportional. So Mr. 3 over 4 will be equal 6 over A. Cross multiplication. You can get the answer. Okay, you can get the answer by using the cross multiplication, so it will be 8, of course. Yes. Okay. Okay. So it's very easy, as you see. We're going to number 2. In the opposite figure, the two triangles are similar. Okay. Then what is the value of x? What is the value of x? Where is the triangles which are similar? Pay attention with me, please. The two triangles are overlapping, as you see. So pay attention, please. Okay. I have the first triangle is the whole triangle that I'll color it by the red color. طب what is the small triangle? I'll color it by the blue color. The small triangle, only this triangle, only this one. So I make the relation between the first triangle, the whole triangle, and the second triangle is the blue one. Okay, let's start. Okay, mister. So in the first triangle, I have this side is 15. Okay, so I just write 15. And the corresponding side is excellent. It's a 5. Okay, mister. In the big triangle, this side is 18. So I just write 18 over x. It means the biggest side, which is x. Okay, so I can get the answer. It's 6. Excellent for my dear students who give me the answer. So it's 6 by using cross multiplication. Also. Okay. Okay. We're going to number 3. Number 3, if the length of the shadow of a mosque minaret is 15, and the height of the mosque wall is 2.5 meters. The length of the hole's shadow is 1.5. Then what is the height of the minaret? Pay attention, this is a real life application for the proportion. So I make like this. Okay, you will make like this. Yes, and I'll start work in this proportion. So the height of the minaret over the shadow of the minaret. The height of the monarch, is missing the height of the monarch. So I just write X, just write Y, and so on. Over the shadow of the monarch. The shadow of the monarch is 15. The shadow of the monarch is 15. So I just write 15. Okay. And here, the height of the wall, the height of the wall is 2.5. Okay. And I have here 1.5 for the shadow. So I just write 1.5. Make cross multiplication. The problem has been finished. The problem has been finished. Okay, so it's equal to, yes, excellent, 25. Okay, so this is the answer for number 3. We're going to number 4. In number 4, two triangles in the opposite figure are similar. What is the value of x? What is the value of x? Okay, just start. I'm going to the small triangle, which is MNQ. MNQ, this side is 9. Okay, so I just write 9 over the whole triangle MOP. This side is what? Excellent. It's a 12. 9 plus 3. Okay, it's equal to the other side. The small here part is 15. So I just write the small part is 15. The big part is what? Pay attention with me, please. The big part or the side, the total side is MP. Is MP. Okay. I just write MP now. I just write MP now. Okay. And make a cross multiplication. So make a cross multiplication. So MP is equal to 12 times 15 over 9. It's better to cancel. I divide by 3 equals to 4. I divide by 3 equals to 5. 4 times 5 equals 20. So MP equals to 20. MP equals to what? 20. I don't have 20. If you are wrong. No. But pay attention. I need to find the value of x, not the value of MP. MP is equal to 20. And this part is 15. So the remainder will be what? Yes, excellent. It's 5. Excellent. It's 5. Okay. So the value of x is 5. So just I'll determine the small triangle and the big triangle. The small triangle is MNQ. So I just write triangle MNQ. And it's similar to the triangle MOP. And then after that, I write the proportion. And then after that, from the proportion, I find that whole side MB, the part of this side is 15, so the other part will be. I hope everything is clear now. I hope everything is clear now. Okay, we're going to number 5. Number 5, two rectangles are similar. Two rectangles are similar. If the scale factor of the similarity between them is 5 to 3, is 5 to 3. Okay, and the perimeter of the largest triangle is 65. Then what is the perimeter of the smaller triangle? The part or the point that we took on the discussion. I have here a proportion like this. Okay, Mister, you said the proportion or the scale factor of the similarity is 5 over 3. Okay, and the perimeter of the larger is 65. So I put 65 up and down. 5 is greater, so 65 is opposite to 5. Okay, I need to find the perimeter of the smaller, so I can name it by X, by question mark, no problem, and get this result, and get the result, which is what? Yes, it's 39. You can use the cross product, or 5 here becomes a 65. I multiply it by 13. So 3 multiplied by 13, it's equal to 39. Or by cross product, 3 multiplied by 65 over 5. By the same way, cancel here 5, cancel here, becomes a 13. 13 times 3 is 39. Anyway, this is your decision to use any way by or any method to calculate your answer. Number 6, if the two triangles JLM and QST are similar, find the value of X. So pay attention. Pay attention here. The two triangles are flipped. So in order not to confuse, use the umbrella rule from here, from the name. If you have two triangles in the same order, I can leave you without names, but I give you the names here in order that these two triangles are flipped, are not in the same order. So you can use the name. Okay, I can use the name, find the value of X. I'm going X, which is MLM. So I need LM. So, Mr., you will see. I just write the first two letter with the first two letters. So, Mr., I just write JL over first two letter QS is equal to the second two letters. We have LM, which over ST equal, yes, complete the umbrella. It means the third letter with the first. So MJ over TQ equals to, substitute please. We have JL. JL is missing. Okay. And SQ is 4. So JL is missing. So I just write JL. Over what? Over SQ is 4. Equal LM. LM is 6x minus 3 over ST. ST is 3. Still, to finish this problem, you must have a completed ratio. A completed ratio. Okay. So this is not complete, the first, and the second is not complete. I'm going to the third, must be completed. Must be complete. MJ. MJ is 4. What about TQ? TQ is 2. Oh, this is a completed one. No need for the beginning. I need to find the value of X, so I just use this. Okay, so I'm going to 4 over 2. It means 2 over 1. So I just multiply by cross multiplication like this. So 6x minus 3 multiplied by 1, it means 6x minus 3 equals 3 times 2, which is equal to 6. Plus 3 to both sides. So 6x equals to 9. And then after that, divided by 6, and get the answer. So the answer here will be what? 6 over 9 divided by 3, it will be 3 over 2. It means 1.5. So the value of X here is 1.5. Okay. So this is the result of number 6. This is the result of number 6. The order of the letters must be the same. Pay attention about this point. Okay. Okay. We're going to number 7. In number 7, if we have this quad, which is BQRS, and the other quad, JKLM, and the scale factor of the similarity, pay attention about the order. Start by BQRS to JKLM. Is what? Is 4 over 3, or 4 to 3. So this is the scale factor. And QR is equal to 8. Then what is the length of QL? What is the length of QL? So pay attention. Sorry, KL. So QR. So I just write QR. QR, it means the second and the third letter. So I just write here QR. QR. So QR. So I just write QR. And 3, which corresponding to KL, the second and the third. Okay, so I just write KL. Yes, now there is no problem. QR is 8, so I just write here 8. So by using cross multiplication, you can use the result, or 4 becomes 8 multiplied by 2. So you will multiply also down by 2, multiply 3 by 2. So it's equal to 6. And this is the answer. Okay. Okay. Mister, but we work here in a quad. There is no problem. in a quad, in a pentagon, in a hexagon, no problem about the shape. No problem about the shape. Okay, we going to number 8. We going to number 8. In number 8, triangle ABC. If DE is a bisector segment, DE is a bisector segment. It means what is a bisector segment? It means E is a midpoint of AC and D is a midpoint of BC. Okay, mister. So this is the meaning of bisector segment. It means this equal to this and this equal to this. Okay. Which of the following statement is not true? Which of the following statement is not true? Okay. Triangle ABC is similar to triangle ADE. Of course, they are similar. So this is right. DE is parallel to BC. Yes, this line is parallel to the third side and half its length. So this is right also. So this is right and this is right. Measure of angle 1 is congruent or congruent to angle 4. Angle 1 is congruent to angle 4. From where? I think this is not right. Okay, so this is not right. Okay. AD over DB equal AE over EC. So this is right also. So the answer will be letter C. The answer will be letter C. Why again? The answer will be letter C because the angles here are equal, the corresponding angles, because this line is parallel to this side. So angle 2 and angle 4 are corresponding. Angle 1 and angle 3 are corresponding. So angle 2 equal to 4, 1 equal to 3. 1 equal to 4, it's wrong. So this is our answer because he said is not true. Okay. Okay, my dear students, this is the end of this session. This is the end of this session. By this session, already we solved it or we talk about the similarity in triangles and similarity in polygons, and we solve some problems that related to this part. Inshallah, the next part or the next session will talk about the conic sections. The conic sections, the parabola, hyperbola, ellipse, and the equation of the circle. This is a very important part, and this is the last part in geometry. Inshallah, our sessions for the next week will be only the next week because after that, will be Ramadan. So we'll change the time of the sessions again in Ramadan, inshallah. Okay, so for the next week only, we will work inshallah together. We will work together inshallah. Sunday, Tuesday, and Thursday, and I'll send the time inshallah in the group for the next 3 sessions for Sunday inshallah, Tuesday, and Thursday for the next week, and then after that we'll use a new time for Ramadan or Ramadan timing. Thanks for your attention. And inshallah, I'll send these 2 sessions or the record for the 2 sessions, inshallah, in the group. Also, I'll send a small exercise. Try to finish it and send it to me. For some students, don't send the last exercise. So please try to send the 2 exercises together. Thanks and see you, inshallah, and have a nice time. See you, inshallah, by the end of the first day in the school, inshallah, Sunday. Thanks and goodbye.